Hello everyone, welcome to the Industry Tech Talk on evolving trends in transformer protection and an overview of 845 transformer protection system. My name is Vijay Muthukrishnan. I am the Senior Engineering Manager with GE Multilane. I've been with GE for about 15 years, responsible for a variety of roles, all the way starting as a field engineer, application engineer, now responsible to lead product development and research in GE Multilane. Today, we'll be covering several topics around the evolving trends in transformer protection, all the way starting from understanding the scale of transformer protection application and going into various pillars of solutions of transformer protection that allow you to maximize the life of the transformer. The first one essentially trying to understand is that the transformers are the workhorses of, you can say, a transmission grid, a power grid essentially. They really allow the generation end to the distribution end, power transportation, make it happen. So in this context, if you think about your transformer protection application should be able to fit into a generating station applications when you are actually stepping up the voltage into transmission levels, various voltage levels of transmission applications, sub-transmission, all the way to a distribution and industry applications. You have variety of transformers, transformer types, transformer capacities. So we are really looking at a transformer protection application that can fit in variety of these customer segments. Now, when you really think about further, what is it that can be best in class in transformer protection? What are all the various dimensions of a best in class transformer protection relay? So the fundamental aspect of any protection relay is reliability. In protection philosophy, reliability can be looked at in two dimensions. One, dependability of protection. The dependability of protection means is the ability of the protection relay to clearly remove the fault when there is an in-zone fault in the fastest manner possible, number one. The real impact of that speed can be felt by reduction of stress on the transformer as well as preventing serious damage. This is one dimension of reliability. The second dimension of reliability for a transformer protection relay is around security of protection. You really don't want your transformer protection relay to operate when you don't want it to operate for conditions like such as through faults or external faults. So the relay has to have some adaptive signal processing capabilities to make it happen so that you can avoid your availability challenges on the transformer in the context of your system operation. These two aspects of reliability. Now the third one comes into picture as you have a variety of transformers. You may have a system that is old in which you have systems of protection that are discrete in nature. You have multiple relays put together as a scheme and deployed for a transformer protection. Can you actually have a device that can converge these applications and meet all your variety of application needs all the way from a 2-winding, 3-winding, or even multi-terminal transformer applications? That is the third pillar when it comes to best-in-class transformer protection. Now, this is meeting your application need. You can just leave this much into a transformer protection relay and it will sit there and protect your transformer. But you want that device to be connected to the rest of your network, have the ability to build interlocks, control the breakers using the same relay. There comes, you need really looking for interoperability as a next stage. Here comes a variety of networking architectures. It can be a simple Ethernet or a dual Ethernet, advanced PRP for reliable networking communications, or a very, very basic of serial communication. You can have any type of networks in your system. On top of that, you add variety of protocols like Modbus, DNP, 61850, goes on. Now, you can have this type of a communication architecture. Is that good enough? In the world of cyber threats, a layer of cyber security becomes paramount. That's where your expectation should be. I'm really looking for advanced cybersecurity functionalities that will enable me to be compliant for NERC. So this is the fourth pillar. This again is another level of transformer protection that you can have. The other dimension that has not been touched by the industry in a larger extent is that these transformer protection relays are sitting and watching the transformer 24/7, 365 days, and they really know what's happening in the transformer in terms of monitoring and sensing some of the incipient fault conditions. So can we really use this particular device for enhanced, advanced analytics around asset management, health monitoring of transformer, or monitoring and diagnostics on a continuous basis. That is the next powerful value you can gain out of your protection relay. Now, if I give you all this and make it really complicated to configure, operate, maintain, and use, it's going to be very difficult for you. So it has to be simple to use. It has to make you feel that you can learn this relay within no time, and you can use at the different stages of its life cycle in a simplified manner. Then you will really feel the operational efficiency of having protection relays that are simple to use. Now we will go touch upon into details of each of those areas we talked about, such as the various pillars of best-in-class transformer protection. The first one on the reliability dimension is the dependability of protection. Now, a transformer protection relay, the core of the transformer protection relay is the transformer differential protection. So the traditional approach has been a dual slope characteristics to do differential protection. In GE, we have always had an approach to proven high-speed transformer differential algorithm that is based on a dual slope, dual breakpoint with the spline characteristics in between the two breakpoints. Here, essentially, the slope 1, you set it for internal fault sensitivity. Your breakpoint 1 defines the safe limit of linear CT operation. Your breakpoint 2, you set it around the minimum current when the CT saturation starts. Your slope 2 is more for true fault stability. This is the transformer differential algorithm that is proven for a decade plus years in GE products. Now, what you expect out of this type of a transformer relay is also that you expect an internal phase and magnitude compensation. You expect a dynamic compensation for tap changer positions. And then it will be ideal if the transformer protection relay does not impose any limit on magnitude compensation factor for CT ratio mismatch. And on top of all this, if you can get a subcycle operating time for certain fault conditions, that will be really awesome in terms of how do you expect the speed of operation for your transformer protection relay in order to isolate internal faults. Now, what are the proof points around it? A transformer protection relay has to go through significant amount of real-time digital simulation type of dynamic testing, like the one you're seeing here, results out of our 845 transformer protection relay. Here is a sample. You have a system of a transformer with the sources feeding on either side, and then you can simulate different types of faults, phase-to-ground fault, phase-to-phase fault, three-phase faults in the zone of the transformer to simulate an internal fault. That's what you see on the table to my left, where we have created, this is a sample of the test cases we have run, but there can be hundreds of cases that can be simulated using RTDS and study the performance of transformer protection relay. This is how you prove the speed of operation of a transformer protection relay. Now, the differential functionality can give you coverage for certain percentage of the winding. Obviously, the winding that is closer to the neutral end of the transformer will, if the fault is there in that particular portion, you will definitely have challenges to detect it using differential functionality. That's where you need restricted earth fault, which is meant for low level of fault current functionalities towards the neutral. So any transformer protection relay that you are looking at should be able to support enough number of restricted ground fault protection. For example, you have a 3-winding application, 2-winding application, you should be able to apply restricted ground fault up to 3 windings depending on your nature of the winding configurations. And the operating speed of restricted ground fault protection can also make a big difference. A 25 millisecond operating time in the case of an 845 really is a high speed for a restricted earth fault protection operation. Again, the value here is you are isolating the fault, reducing the stress on the transformer, and preventing serious damage to the transformer. This is on the dependability aspect of the differential protection. Now, moving on to the next dimension of security of protection. I mentioned that security is nothing but stability of transformer protection for through faults or external faults. Now, we have the dual slope, dual breakpoint characteristics. You can use the second slope to a certain extent to achieve through fault stability. However, technology in terms of innovation further in advancing and applying principles like CT saturation detection and directional supervision really enhances and takes the stability for true false to the next level. And that's what you see here in this particular slide. A technique that is deployed in 845 actually can detect, is there a true fault happening in my transformer? Is my CT saturating? Yes, I would like to make my relay secure with a directional supervision functionality. This essentially prevents misoperation for a true false and ensures that you don't get into availability of your asset in terms of sudden shutdown of the transformer and your system is affected. Those types of problems does not happen when you have a solid true false stability through CT saturation detection and directional supervision. Again, in terms of proof points, you should be able to test your transformer protection relay, look at the performance for various conditions of true false. So in this case, I'm showing an example of, again, the same system of a transformer fed by both end sources in RTDS and creating various types of faults. In this case, F3 is the fault that is outside the zone of the transformer, and you create different varied degree of CT saturation. You are simulating a real-time system behavior in a modeled environment, and you actually subject your relay through this test. And you can see a relay without directional check and CT saturation operates for an external fault about 70% of the fault cases, whereas an 845 is stable for all those fault conditions. That's really powerful in terms of true false stability. Okay, having understood the core of the transformer differential functionalities, now let's move on to the coverage of applications. What I mean by coverage of applications is that the nature of a transformer and the way it fits into your context of your system has a variability. You pick certain particular application for your transformer protection based on the nature of your application. So I'm going to cover some typical scenarios that you come across and explain how varied it can be and how a transformer protection relay should have capability to fit all those types of applications so that the device you pick meets your requirements. The first most common application of transformers you see is the two-winding transformer application without any voltage. This is more common probably on the medium voltage applications and probably a little bit around the sub-transmission applications, where you pretty much would use the core functionalities of a transformer protection, be it a differential protection, restricted ground fault, have simple thermal elements, a lockout protection with a overcurrent backup and a ground fault backup elements. This is what a simplified or simplistic transformer application can contain. In the case of our Multilin 845 device, you can easily achieve this with an 8CT analog subsystem and a single combo I/O card that has 5 outputs and 7 digital inputs can meet this particular need in a simpler manner. If you want to add a little bit of monitoring functionalities into your transformer protection relay, you can definitely add the low voltage analog card module that brings in DC milliampere inputs and outputs with RTD inputs. So that gives you a base level of monitoring functionality for a transformer application like this. The next one is same two-winding transformer application, but with voltage input coming into your transformer protection relay. This again varies all the way from medium voltage and more common in transmission and sub-transmission applications. In this application scenario, on top of your core differential, restricted ground fault, and overcurrent based functionality, now you have the ability to apply protection functions like volts per hertz, which is a very important function when it comes to transformers to detect overexcitation conditions, over voltage. There can be transient over voltages in the system that stress the transformer. So you must be able to identify those conditions and isolate them. Directional overcurrent, in terms of how your system is designed, you want to actually have a directional backup functionality, you can have that. You can use the transformer protection relay as directional power and various other energy metering functionalities. On top of that, you can also use for synchro check functionality. Say, for instance, you have a generator step-up transformer condition, you can use a synchro check functionality in a scenario like that. In medium voltage application, you are also going to benefit by having an integrated R flash protection module that can detect R flash. That's the scope of protection functionalities you can expect when you have a two-winding application transformer protection with voltage input coming in. In our 845 transformer protection relay, you can achieve this easily by having a 8CT current analog subsystem and add on with a 4VT voltage subsystem combined with a combo IO box. That can give you the base level of protection. Now, the power of 845 is such that you can actually have a base level of monitoring added to your transformer protection by just bringing in one analog, low voltage analog IO subsystem, or by adding a couple of more RTD cards, which can allow you to have up to 13 RTDs and two combo IO cards, scaling up your outputs and input requirements. You can really build a very comprehensive monitoring and a little bit of even control for your transformer in a holistic manner. That type of application is very comprehensive, that meets your protection, monitoring, diagnostics, and control requirements in your application. That's very powerful. The next, two-winding applications we saw. The same way, when you have a need for a three-winding transformer application, the way you really look at it is that your transformer protection relay should be able to process three-winding input currents, do the phase internal and magnitude internal compensations, and do the differential protection with the three-winding currents coming into the protection relay, able to support you up to 3 restricted ground fault elements if you need in your application, and on top of that add all the voltage based protections, the integrated R flash, those type of scenarios. So this is the comprehensive approach when you have a three-winding transformer. In the 845 protection relay, you can easily achieve this by having up to 12 CT inputs as analog subsystems coming in and a 4VT input module combined with either a single or dual combo IO boards that gives you binary inputs and outputs. This can be a base level of protection device for your three-winding applications. In the same way I mentioned, you can expand into a basic level of monitoring or a very comprehensive monitoring and diagnostic functionalities integrated into the 845 itself. That's how you meet your three-winding transformer application requirements. Then the other type of application that comes is the breaker and a half scheme, where for two-winding transformers. In this case, it's essentially you have to treat it as a three-winding transformer application in case of an 845, and you pick an order code option that allows you a three-winding application, but you are applying it for a two-winding with breaker and a half schemes, and you can do three-breaker control as well within the same device. That's how you actually can build a protection built on monitoring and a comprehensive monitoring and diagnostics for a two-winding transformer with breaker and a half application. Auto transformers is another common application that you see more in the transmission space. This can be also met by a similar to a two-winding transformer application. The core functionalities remain the same between the two. You can actually build differential, restricted ground fault, and voltage-based overfluxing and etc. functionalities for auto transformers, and 845 can easily meet this need also. The next application is auto transformers with breaker and a half scheme. This is in the same way we talked about a two-winding transformer with breaker and a half scheme. You will pick a three-winding application ordering options in 845 in order to deploy it for an auto transformer with breaker and a half scheme. Rest of the monitoring and diagnostic functionalities remain common across any of the application scenario you are picking. The next application is also unique. Generator step-up transformers. You can view it in two different ways. The first is protecting the step-up transformer as a transformer alone, essentially. That's the first application I'm discussing. The majority of them are two-winding applications. In this case, you can also have a three-winding step-up transformer where you end up having two generators connected to one each of your medium voltage windings, and then you have a high voltage winding that is one connected to your grid. This type of application also can be protected with 845. Whether it is a two-winding or three-winding, a similar approach will be adopted. The next case is where you consider the generator and the step-up transformer as a single zone, and you provide an overall differential. Here you are essentially applying a transformer differential protection for the zone of a combined generator and transformer. So you will treat this as a two-winding an application when you have a generator connected to a two-winding transformer. You can have an overall differential relay that is equivalent of a three-winding application if you have a common step-up transformer for two generators. That is also possible. Apart from the application need change, the type of protection you apply remains similar to a two-winding and three-winding applications. You will, in the case of a combined zone, you will apply the phase and magnitude compensation for one end. The other end will not have any phase and magnitude compensation, so to say, because you treat it as a base line. And the monitoring and diagnostic functionalities are applicable across the same applications. Now, the last aspect in terms of protection functionality is the integrated arc flash. I briefly mentioned about this is more applicable for medium voltage switchgear. If you have a switchgear lineup that has a combination of motor protection relay, feeder protection relay, and transformer protection relay, your ability to deploy an integrated arc flash module in all of them will become very powerful. It gives you a comprehensive arc flash detection and mitigation strategy in your medium voltage application. So the 845, for example, can support up to 4 optical sensors and detect light, supervised with overcurrent, which is a fast operating instantaneous overcurrent functionality. And it's very simple to set it up, and it has built-in self-diagnostics that can actually let you know when the sensor circuit has any problems. So this type of integrated arc flash protection allows you to build a simplified arc flash solution. Having covered the variety of application needs on the protection side, let's focus a little bit on the advanced logic and control functionality. We have a relay. If that relay is able to give you a very good visualization like the 845 with a single line diagram and an intuitive summary of information that you would look for in terms of operational characteristics and parameters of the transformer, that will be very useful for a maintenance and operational perspective. So the single line diagram with a summary information is the step one. Then you should be able to control the breaker either locally through breaker selection and open trip breakers, or remotely. You up to 3 breaker control functionalities for a 3-winding application would be really an add-on value for a transformer protection relay. In a 62850 system, completely integrating into your HMI through logical nodes for measurements and interlock will be the next level of control you can accomplish. But you may also have several control functionalities. For instance, you want to build a custom logic based on some of the cooling system inputs of the transformer. So you can build some custom flux logic in your transformer protection relay to manage that. So up to 1024 lines of flux logic, for example, are available in 845 that you can use for that purpose. You're also bringing in several parameters, measurements like top oil temperature, winding temperature, and so on and so forth. When you bring this type of analog input through a DC milliampere or an RTD input, if you have customizable monitoring or protection elements that you can use in the form of a flux elements as it is available in 845, you can actually build custom applications in your protection relay that can be very powerful and useful in your specific application needs. So that's another aspect. So the value of this is that it allows you to simplify your scheme by eliminating discrete devices you may have in different various areas. You can integrate them into 845 protection device. Now, let's moving on to some of the tools that you normally use for troubleshooting. When you actually have a fault, whether it is a through fault or an internal fault, what type of tools are available within the protection relay that you can use to simplify and make it fast and accurate analysis after the event. So the first one is the transient recorder or oscillography. So the transformer protection relays should be able to provide almost a DFR class transient recorder with the sampling rates as high as 128 samples, with the ability to configure the sampling rate you want to pick, up to 25 seconds of storage depending on the sampling rate you choose, and a software tool that is very easy to use and visualize the comp rate files and make sense out of what type of fault has happened, where the fault is, and what actions you want to take. Especially if you have a substation and in the substation fault happened and the fault is seen by multiple relays, an ability to merge the comp rate files in a simple utility as part of the software program becomes very useful, because now you can grab data from multiple relays, combine them into a single COM thread, time align them, and make sense out of the entire system phenomena, what happened in that particular fault condition. That is the power of transient recorder functionality. Now, we talked about transient recorder being useful for fault conditions. At the same time, the relay is collecting a lot of information, be it electrical, thermal, characteristics, temperature, etc. If you have an ability to continuously log and trend them, you can build custom applications to trend certain parameters. For instance, load current and temperature over a period of time. See what happens. How does it trend? Do you see any varying trends that is worrying you? So you can build some application in terms of operational effectiveness of your transformer asset. Also, in an engineering perspective, you can actually do time coordinated sampling of calculated parameters across multiple relays and try to validate your protection coordination, for instance, is another application where you can use. In this data logger functionality, if you are able to have the ability to trend or capture any instantaneous values, or over a period of time, the minimum value, maximum value, or average of that value, you really have a very powerful operational tool in your hand. And that's what 845 can offer to you. The next one is fault report and event records. These two are more driven around fault and any alarm or events happening as seen by the transformer. A fault report can give you pre and post fault snapshot of the data in terms of electrical characteristics. Event records on a sequential basis log all the different events happening as triggered seen by the relay itself. So the timestamp resolution of these events can be less than 1 millisecond as it is in 845. And the capability, like if you program a debounce timer in order to manage your contact bouncing, the relay should have the ability to backdate the timestamps so that you get to clearly see the first instant that particular contact input got triggered. So these are some fundamental functionalities that can allow you to do fast and accurate fault analysis. Now that we have covered varieties of protection, control, and logic functionalities that are part of a transformer protection relay, let's look at from a communication and networking aspects and cyber security front of what is it that a transformer protection relay needs to offer, can offer. So when you think about it, the real need here is you want to be able to connect to your transformer protection relay and pull information, deploy control commands through the communication network. You may have a very simple versus to a very advanced communication architecture in your application. So the expectation on a transformer protection relay should be, does it offer you very flexible, scalable, interoperable communication? This is the foundation block that you want to look at. So in case of an 845 multi-link transformer protection relay, you can see the type of architecture, communication architecture it can support. A simple RS-485 communication, yes, it can be done. A single Ethernet port with copper, possible. You go into a dual redundant Ethernet with failover, you can do it. Dual redundant Ethernet with PRP mechanism, you can do it. So as you can see, very simple to a very advanced communication architecture is possible in the product. On top of that, for general engineering and maintenance access, you can have a simple USB port or something like a very useful and powerful Wi-Fi mechanism. Many customers may think Wi-Fi means it's too far for a protection relay. But when you really look into the application scenarios, you can deploy Wi-Fi. Be it, you can think it from a safety perspective. An operator need not go near a protection relay and pull information, records and everything easily possible. Or if you're doing a factory acceptance test or a site acceptance test, for you can actually have a simplified configuration, set up everything using a Wi-Fi access from a laptop. That's the power of the functionalities like Wi-Fi. Now going into protocols itself, once you have your base level of network architecture cleared up, now get into the protocols. Application demands variety of protocols. The simplest can be a Modbus all the way to the most recent edition 2 of 61850. The device should be able to support that. 845 is an 61850 edition 2 compliant device. So it supports Modbus 103, 104, DNP, and above all it also has OPC UA, which is very unique, and only 845 series product lines have the OPC UA in the industry, and our 3 series product line also has OPC UA as part of the communication protocols offering. So once you have these, you have the ability to meet your network needs and pull the data over any type of protocols you really need. On top of that, the recent evolution in the industry has been that cyber threats are more and more real. You are protecting your critical infrastructure from cyber vulnerabilities is an important requirement. And there are some mandates in geographies like North America for you to have NERC compliant cybersecurity functionalities in your protection relay. So to make that happen, for example, 845 offers you a very solid, comprehensive set of cybersecurity functionalities, such as role-based access, password complexity, remote authentication using radius server. You can actually have security event reporting over syslog, a bunch of cybersecurity driven functionalities. And also the product is subjected to World Tech Achilles cybersecurity vulnerability robustness testing, penetration testing to prove that the device is solid in terms of functionality when it comes to cyber vulnerabilities. So putting this together, you can have any type of requirement, simple to advanced. You have a relay that can meet your need is the real value that you will get out of picking a product like 845. Now, digging a little bit deeper into some of these aspects like 61850. When you think about it, 61850 is a standard that really brought in to drive interoperability as a key requirement. Now with the 8 series platform, if you take it as an example, it comes with a single CID file that is based on a standard XML SCL formatting, which combines both the 61850 configurations as well as the protection configurations into a single file. This is not common in the industry when you think about it. Variety of ways of doing are there. One of them is you have the 61850 configurations handled by the XML formats, and then you have a proprietary way of handling the protection settings. The power of integrating them and giving you a single CID or an ICD file is that you can actually deploy that file directly to the relay without the need of the setup program or the software for that particular device itself, which allows you to centrally manage your config file deployment. Some of the users, depending on the way and philosophy of how you do centralized config file manage, this is a powerful functionality. The next one is very unique, not there in the industry on protection relays, OPC UA. The classic OPC structure in any process industry or petrochemical industries is that you've always had a translation layer. You have devices, loads and loads of almost a layer of devices that does translation from legacy protocols to OPC. Now this has been there. This concept has been there in the industry for quite some time. But the OPC UA has been introduced and has been evolving in the automation industry for quite a few years now. In the continuation of that is that application of that in protection relays. When you really think about a protection relay having OPC UA embedded in it, your ability to self-configure using a OPC UA, for instance, a simplicity HMI if you are using, you can easily integrate them in a simpler manner. You eliminate almost a layer of devices in your communication architecture. You can add layers of security natively. So there are a lot of benefits by bringing OPC UA into the protection relays itself. So this is another unique benefit both the integrating businesses as well as the end users will feel in a product like 845 and the entire 8 series platform. And digging on one functionality is a little deeper into on the 845, which is related to the advanced security. What I'm showing here is the remote authentication functionality that the 845 relay offers. So the remote authentication is achieved through having a centralized server, radius server that is located in a control center. Now you have relay that is deployed in a substation. A local user goes, connects to the relay and says, here is my username, this is my role, and this is my password. The relay will immediately pass on that user credentials into the radius server and wait for feedback from the radius server. When the radius server tells the user, yes, I can recognize the user and the password, the relay will determine, okay, I'm going to let this individual access me. If the radius server says either a username is wrong or the password is wrong, the relay is going to block the access for the particular individual who is trying to get access into. It is a very simple and powerful way of implementing a role-based access in your entire protection relay fleet and manage the remote authentication and account management in your system. All right, let's continue in terms of the next area of exploration in this discussion. This is where it's very unique, very evolving trend in the industry. See, when you think about a transformer protection relay, traditionally you only imagine the functionality of a transformer protection relay to be you better detect a fault and trip the breaker when there is an internal fault, and you stay stable when there is an external fault. This is the most simplified understanding of a transformer protection relay. With some metering and measurement functionalities, you have some capabilities of looking at what is happening in the transformer. But we really have, in the older technologies, we couldn't achieve much more. Whereas the technology now allows you to do a lot more processing, a lot more data collection within the transformer protection relay. And if the transformer protection relay that is watching the transformer 24/7, 365 days continuously, the power of collecting and interpreting the data and using that to do asset management capabilities will be very valuable in terms of extending the life of the transformer. That's where the next trend of transformer protection is towards asset management. What are the functionalities of monitoring and diagnostics you have within the device? So you can have a simple protection relay with basic monitoring functionalities, like it can monitor aspects of your breaker, some level of harmonics, and give you some basic RTDs to do temperature monitoring. This is one level. If you slightly go up to the next level, the IEEE and IEC standards define how you can calculate internal parameters of the transformer, such as hotspot temperatures or interpolated age of life, aging factor, loss of life, harmonic derating factor type of parameters. Adding this type of thermal analysis becomes the second level of monitoring that you can do in any transformer protection relay. At the most, you would have seen this much in the past in any transformer protection relay. Now, whereas when you think about new areas, that's where a relay like 845 offers you tremendous value, because it gives you a much more asset management functionalities on top of the standard monitoring features you are used to see. So learned data is a great example. The idea of the learned data is essentially you can view into the last 1 year of your transformer, look at the behavior of electrical characteristics within that 1 year, and make sense out of operational behaviors that you have seen in your transformer, and understand how your transformer has operated. Are there any indications of problems within the transformer? It's one example. Energization record is another nice functionality, where you have the protection relay can capture the first 10 cycles of raw current samples whenever a transformer is energized, and use it to calculate things like maximum inrush current. It can also capture voltage samples and give you what was the voltage dip experienced by the system when you energize the transformer, so on and so forth. That's again a very accurate way of characterizing energization behavior over a period of time. Transformer models. Here is a group of functionalities that are brought into 845 in an integrated way. See, we have a portfolio of dissolved gas analyzers within GE. It's a approach of monitoring, online monitoring of transformers using dissolved gas analyzers. Now, the offering that we have on 845 is an integrated solution that brings both the electrical characteristics as well as the chemical characteristics together, and gives you analytics built on the combined power of looking at the transformer in a holistic manner, and give you intelligence that tells you what is wrong in a transformer. Say, for instance, you have an incipient fault developing in a transformer after a true fault condition. The relay can detect a true fault, and it has the ability to know what happened before the fault electrically, chemically, and what is happening in the transformer after the fault electrically, chemically. If this data is presented to you in a meaningful and interpretable way, you have a very powerful analytical tool in your hand to make decisions about the condition of your transformer, take preventive actions, and over the life of the transformer, really put in practices that allow you to extend the life of the transformer itself. So the core idea behind this integrated monitoring and diagnostics is to enable you to extend the life of the transformer. Now, just going into how does it really work. So think about, if you have a transformer, you are going to bring in electrical CTs and VTs into the transformer protection relay. You're going to bring in all the possible temperature monitoring into your relay. You're going to bring in any other analog parameter measurements through your DC milliampere inputs. Now you have the ability to connect to a dissolved gas analyzer through communication means into the protection relay. You can also bring your entire cooling system inputs through the into the 845 protection relay. You can bring in your tap changer inputs either through a potentiometer or through a BCD digital inputs or using DC milliampere input. And when you step back and think about it, today you may be having multiple devices out there along with the protection relay to do your protection plus monitoring and control functionalities. Now we are saying a single device such as an 845 transformer protection relay can give you a very comprehensive integration of these functionalities and eliminate the discrete devices and offer you that value which will be very powerful along the life of the transformer. The next area is to look out in a transformer protection relay is that what are the functionalities the relay can offer you to monitor the health of your breaker also. Because it's not just transformer that your relay is interacting with, the relay is also closing and tripping the breaker. So can the relay provide you a good amount of analytics around a breaker? So in case of an 845, you can see it can track open and close times. It provides you trip circuit monitoring. It can also give you contact wear through per phase arcing current, spring charging time, and trip counters. The idea behind this set of breaker health monitoring functionality is that can you use these effectively by over a period of time looking at this data, shift from a schedule-based maintenance to more from a condition-based maintenance. That's the idea behind giving you a breaker monitoring functionalities, breaker health report type of features as part of 8 series functionality. Now, this kind of concludes what we can do in the 845 relay on monitoring and diagnostic features. Now, moving on, we talked about the reliability of protection. We talked about comprehensive coverage for applications. We talked about interoperability, security, and monitoring and diagnostics. The real power of all this can be felt only when you have a device that is easy to use, when you have a device that is easy to integrate into the rest of the system, when you have a device that gives you in a simple manner analytics that you can consume and make decisions quickly. That's where the ease of use becomes very powerful. Our 845 relay with the Enervista suite of setup programs gives you a very intuitive user interface that is easy to understand. You can train your operators and engineers very fast in order to interface with the relay and improve overall efficiency in different stages of the life cycle of the product, either be the relay or the asset. So starting with a quick setup is a functionality, something similar to what you can do with this setup is that if you have a simple need to configure the core protection functions of the transformer, you can do it in minutes. If you are doing a factory acceptance testing or a site acceptance testing, you can quickly configure the device and start performing your testing in a very easy manner. That's the value behind this feature. The next one is another powerful feature in our Enervista setup program called Protection Summary. We have taken a lot of enhancements around this Protection Summary, especially around in 845 and overall 8 series platform. When you think about 845, you have, let's say, assume a 3-winding application. So that means you have 3 breakers connected to the transformer and the relay is seeing and controlling all the 3 breakers. You are defining your protection elements such a way, certain elements you want to trip all the 3 breakers, certain elements you want to just trip 1 breaker, in some other elements you want to trip 2 breakers, or some of them are on alarm elements. In order to do this, traditionally you would end up building a logic in your relay and build that logic into an output relay driving. All these things can be simplified from a single screen. You don't have to do a flux logic or any other logic editing to build this type of common complex schemes of trip matrices. You can do it from a single screen of protection summary, and also within the protection summary, you can view what are the elements that I have configured for just tripping, what are the elements I'm using it for alarm, what are the elements I'm using it as monitoring. In a single snapshot, you can view and make engineering decisions on, okay, this is what I am doing, this is how it is configured, it makes sense to me, I'm happy with it, move on. your whole process of building set point files and validating set point files can be made very, very simple and fast. Then the next one is, okay, you have been able to do without any logic a good deal of your functionalities. But there are cases where you want to build some custom interlocks, you want to build some custom control logics, such as cooling control logic, or you want to do upstream interlock with the device that you have. You want to do some flux logic functionalities. We provide an ability to do graphical way of programming the logic in a graphical editor, and even when you have built it, you want to test it, you have a graphical way of following through real time the state of various intermediary states within your flux logic engine and test those flux logic you have built. It really expedites your ability to build logic and test your logic. That is the value behind these functionalities. Now, in conclusion, when we started off thinking about what is it a best-in-class transformer protection can offer to you. And I've kind of walked you through the various pillars of a best-in-class transformer protection and some details around each one of them. So I'm just going to wrap up saying the foremost important thing is dependability on the protection relay when it comes to transformer protections. So the relay has to be fast so you can reduce the stress on the transformer and prevent serious damage. The next pillar is security of protection. Your relay has to be solid for true fault conditions. So it needs to have advanced functionalities like directional supervision, CT saturation condition to make your differential to be stable for true fault conditions. Then your ability to apply to a variety of simple to most complex applications and allow you to eliminate discrete devices and converge all of them into the protection relay so that you can cover a variety of applications. This device should be seamless to integrate into any type of network architectures on any type of protocol built on a layer of security. Asset management capabilities to let you extend the life of the transformer, making it very easy to use. Thank you very much for attending the webinar.